Okay. In this video, we're going to do a little bit more with the Peel method, maybe get a little bit bigger idea into some of our using our trig functions. So here, sine to the fifth of x over 2, I just want to make a quick substitution right away that I think will make our life easier if we don't have to look at the x over 2. I'm going to make w equal to x over 2. So dw will be equal to 1/2 dx. So I can multiply by 2. And that way, let me write this over here, we just don't have quite as much ugly stuff to look at, right? We got a sine to the fifth of just w dw. Now the Peel method, remember, says we should peel a trig function off the odd power. So let me do that. Okay, 2, the sine fourth of w multiplied by sine of w dw. Okay, so it's still sine to the fifth, but, and the reason you do this is because to do substitution you need different trig functions. They can't all be sines. We need other trig functions. So I'm going to replace this sine to the fourth. Okay, let me do that right over here. So instead of sine to the fourth, I'm going to have 1 minus cosine squared. Okay, so you see I just replaced that sine to the fourth with 1 minus cosine squared. Well, now let me do my substitution. U is equal to cosine of w, so du is equal to negative sine of w, dw. Well, I just changed the sign like that. So now my integral becomes negative 2 integral of 1 minus u squared du. And you think, well, okay, how am I going to handle that? Well, now we actually got to multiply it out. So negative 2 integral 1 minus 2u squared plus u to the fourth du. So when I do the integral, the antiderivative, we write the negative 2 here. The antiderivative of 1 is u. We got minus 2/3 u cubed plus 1/5 u to the fifth. And we will have a plus c out here. Now let me do a couple things at once. Let me multiply the negative 2 in to this, and let me also substitute cosine of w for u. So I'm going to have negative 2 cosine w plus 4/3 cosine cubed of w minus 2/5 cosine to the fifth of w plus a constant out here at the end. I kind of run out of room for. And now at the very end, let me put back what w was equal to. Negative 2 cosine of x over 2 plus 4/3 cosine cubed of x over 2 minus 2/5 cosine to the fifth of x over 2 plus a constant. Okay, this up here should have been a constant. It's kind of hard to see. All right, so it's quite a process here. You know, to get from the beginning to the end, you have to. I did the substitution just to make it look a little bit easier. We peeled one of the signs off. We replaced a sign. I did the substitution just like I was doing before. I integrated. I had to multiply it out. I integrated it, and then I resubstituted back in. Now this one is a little bit different. It's not necessarily the Peel method, although it often gets kind of lumped in there with it. And this is just using the trig stuff we know to make some tough integrals easy. So you look up here at what sine squared is equal to. So we're just going to replace. Okay, so I bring my 1/2 up front. We'd have 1 minus the cosine of 2x dx. That. We integrate. I'm going to leave the 1/2 up front. We have x plus 1/2 sine of 2x plus a multiply the 1/2 in, we have 1/2 x plus 1/4 sine of 2x plus c. Like that. Okay. So using some of our trig identities, we can make some kind of hard integrals easier. I want to point out why Peel method would fail here. We'd actually have to do something else. Peel method is really reserved for odd powers, where we can pull them apart and then make the substitutions we want.